Okay, so let's start with the first number. How many sig figs do we have there? Oops.
6.
Okay, everybody agree?
Yes.
Yeah.
Yeah.
Yes.
Anybody disagree? Okay, so the next number, how many sig figs do we have there?
6.
3. Oh, wait. 3.
3.
Oh, wait, there's a dot, yeah.
Okay, what does that dot mean?
That means the zeros are, the trailing zeros after the number are not counted.
Oh, really?
No?
It's for certain.
That means it's for certain. So how many sig figs should I have?
3.
6.
6.
Oh, yeah, my bad.
So the correct answer is 6. Because that dot is there, it's like
Question
putting a
myself.
period on that point and says, no, I'm sure about this, right? So there's 6. How many do we have on the next one?
7.
7.
7.
What about the next one?
3.
3.
Next one?
7.
7.
Next one?
Seven.
The last one?
6.
8.
Correct answer should be 8. Again, it's period. You're telling me now, you're saying all those zeros, I'm sure about that's accurate.
No matter where the period's at?
No matter where that period's at. If you have a decimal there, it lets you know that you're going to count the stuff that's going to be following it.
Okay.
Okay? Bless you. Okay, so piece of cake, not too hard. Okay, so let's say we have all these numbers here, and we have to write them so that there's only 2 significant figures. Just 2 significant figures. How would I write the very first number? And you can also use scientific notation. That's my hint.
Answer, you said 2?
So we want 2 sig figs. So I want the answer in 2 sig figs. That's what I'm looking for. So how would I write it? This first number.
2.
So I'm just going to write 2.
20.
I'm going to write 20. Okay, so I'm going to ask you something. If I owed you $2 trillion, 1,110,000, you'll accept $2?
2, 3, 4, 5, 6, 7, 8. Is it 2 times 10 to the 9th?
So when I write it, 2 times 10 to the 9th.
Is that right?
Let's see.
Question.
I'm going to ask you and your classmates one.
4.
3, 4, 5, 6, 7, 8, 9. So, right, 10 to the 9th. Okay. So, is it just going to be 2? Is that 2 sig figs?
And then the 2.0.
I hear somebody say 0.0.
Ooh.
So, is that 2 sig figs?
Yes.
Yes. So, that is the correct way to write it. Good start, Lorraine. Gotta
Yeah.
finish. Okay, what about the next question? The next one.
.0 times 10 to the 5th power.
Okay, so is it going to be 2.0?
Or 2.3.
Ah, 0.3.
Yeah. Because it's not a 0 after it.
That's right. Okay, what about the next one? Or it could have just written it as
Times 10 to the 5th. 2.4 times 10 to the 5th. Class.
is it to the 5th?
No, because it's not at 5.
To the 6.
To the 6th.
To the 6.
Yep.
1, 2,
1,
3, 4, 5, 6.
4, 5, 6.
Oh.
Okay, what about the next one?
2.3 times 10 to the.
Actually, is it 2.4 because of the 5?
So we're going to use this number. Are we going to round up? Are we going to round down? I mean, are we going to round up or are we going to leave it alone?
We're going to round up.
Are you sure?
Well, no, I'm not positive about anything in this class. I'm learning.
You guys agree with her? Are you going to round up?
Gonna round up.
Don't you keep it the same?
The correct answer, you would keep it the same because there's not a number to push it over the 5, right? So you're right at that 5 since you're not a number. So if there's not a decimal 0.1 to kind of push it over, then it's going to be kept the same.
So if it's asking for 3 sig figs, is that when you would change it?
No, if they're asking for 3 sig figs, it'll be 23.
Oh.
It would be, 235,000. It'd be left alone. You'd leave it exactly alone in that case.
Okay.
So if you would change it if we had a number following the 5. So if I had a 1 here, right, then we'd round up. But
Okay.
since I don't have a 1 here, it's exactly 5, right? So then I leave it alone.
Okay.
No. Okay, so then the answer is 2.3 times 10 to the 5. Okay. So.
Wait, Dr. Henry.
Mhm.
I would have rounded that up.
And you would have
Because-
gotten it wrong.
Why?
Because it's right there at the 5. So according to rules of chemistry and what's rules in your book, if it's right at 5 exactly, it's at 5 exactly. There's not a trailing number. Then that means you would leave this number alone. So if you have 23, 5, let's say 0, 1, 0, right? Again, we're working with 2 sig figs. This pushes it over that number. So then it's 24. And in that case, you would round up.
Okay.
I've been lied to my whole life.
What was that? I know it's ruining your whole life. I'm sorry.
Been lied to.
Yes. So scientifically, this is the way it's supposed to be done. But most people, because they're just like, I don't want to deal with trying to explain it, right? And it's kind of difficult to grasp because you're like, well, it's 5, right? And you've always been taught, if it's equal to 5 or greater, then no. But when it's right at 5 perfectly, when it's perfectly at 5, you're supposed to leave it alone. But if it's slightly over, just by that 1 down here at the 10 spot, then, or even if I had a 1 down here, way down here, it's slightly over, so then I'll round up. Okay. Okay, questions?
So if it was a 6, it would be fine to round it up?
Yeah, if it was greater than 5. So if it's greater than 5, we always round up. Now, if it's at 5 exactly, we leave it alone, right? So that's what this is. This is at 5 exactly, right? This one isn't this greater than 5? Because you have 5 and then you have numbers following it. Wouldn't that be greater than 5?
Correct.
Yeah. Okay, so the rule is if it's greater than 5, we round up. If it's 5 exactly, we're going to round down. Okay, you got it?
Yeah.
Okay, so what about this one? Oops, that was supposed, I'm giving you too many hits there. Okay, what is the answer for this guy?
I got 2.4 times 10 to the 6.
You got 2.4 times 10 to the 6?
Yeah.
Are you sure?
2.5 times 10 to the 5th.
Are you sure?
To the
Five.
negative.
2.5
I'm
times
not
10
sure,
to the
that's what I was
negative
asking.
4th.
Yeah.
2.5 times 10 to the negative 4th. So yeah, we use this number. It's greater than 5. So we're going to be rounding up. And then we have to remember 1, 2, 3, 4. Right? And it's going in the opposite direction.
Oh,
so it's
negative.
Yes. Okay, what about the next one?
That's 1, 2, 3, 4, 5.
3.4.
3.4 times 10 to the negative 5th.
3.4 times 10 to the negative. Okay, piece of cake. And the last one?
Wait, I thought you don't round it. This is
Ooh.
5.
It's the one at the end.
Doesn't that push it over?
Yes.
No, yeah.
Okay,
That pushes
so
it
we'll
over.
take a look at this. That means that this number is greater than 5 because we have a 1 way down here, right? And so that's going to push it over the tipping point. So it's kind of like, okay, so you guys are like a balance, right? And it's perfectly balanced. 5 is that perfect balance. Okay, now as soon as I put just that little speck on there, it pushes it to that tipping point. That's all you're doing. Okay, so when it's perfectly balanced, we're going to say, oh, it's perfectly balanced, it's 5, so it's going to be that 0. We're not going to round up. It's perfectly balanced. But as soon as we push it over, even if it's by a little speck, then that means that we're going to round up. Okay?
All right.
Questions? Concerns? Cash? Okay, so don't forget your placeholders. That is the biggest mistake that's made. You guys are starting out. First answers I was getting, oh, it's 2, it's 20, it's, you know, those are forgetting your placeholders, right? $20 isn't the same thing as 2 trillion, right? Okay, so you feeling pretty good about this? Okay, so let's do one addition and subtraction problem. Okay, let's see. Let's make some changes real quick. And don't everybody yell at me at once. So for
At
that
the
very
2?
first number, where?
The 2?
At the 2. I'm going to draw the line right there at the 2.
The second one.
For the first number. For the
Oh,
very
no,
first
no,
number.
the 4. You're going to do it at the 4.
I'm going to do it at the 4. Are you sure?
No, but I think it's logical from what I've been learning.
So what does that decimal mean again?
Except for that 2, the .02 is going to be a problem.
So what does that decimal mean again?
That's finalized. It's for certain.
So all of these numbers are significant.
So it's
then I'd
going to
be
be a
drawing, so I'd have a total of 6 that are significant. So I'd be drawing after the decimal or at the decimal.
at the decimal.
Okay. So that's for that first one. What about the next one? The next number?
4.
4.
After the 4? What about the next number?
After the 2.
The first 2 or the second 2?
Second.
The 6.
And the last number?
After the last 0 to the right.
Okay. Okay, so which line am I going to use?
First
The
one.
one where the decimals.
So I heard somebody say the first one, and then I heard someone that says the one with the decimals. So is the one with the decimal the furthest to the left?
Oh, no.
Okay, so then the green line. Hopefully nobody's colorblind. Oops. Okay, so we just go through and we add it up.
31. 0300.02.
Okay, so what should be your final answer?
31,000. 02.
31.0 times, no, I don't know.
Okay, so I heard, okay, so let me make sure that I'm getting this right. So did you say 31 point? Is that what you said?
Are we doing scientific?
You can do scientific. Or you can do decimal form.
3.1 times 10 to the 8th?
Or would it be fifth so that the decimal goes back?
1, 2, 3, 4, 5, 6.
Yeah.
Back to the 8th. So you said 5th. Oops. If the decimal's here, right? This is where the decimal's at. Is it not? Or am I just making stuff up?
No, you're right.
That's where the decimal's at.
So, it
So
would
is
be
that 8
-5.
spots? So that's 1, that's 2, that's 3, that's 4, that's 5, that's 6.
Okay.
So shouldn't the answer be 3.1 times 10 to the 6th?
Yes.
Or
-6.
is it -6?
No, because it's a positive number.
Okay, it's a large number. Since it's a large number greater than 1, we know that it can't be a negative, right?
Ding.
Okay, so this is the other way we could wrote it. 3,100,000. Am I going to put a decimal there at the end?
Probably.
I like the way she says that. She's trying to make sure. She's like, if it's wrong, I said probably. That means that there's a possibility that I don't put a decimal. She's hedging her bets there. Is that right, Mandy?
Yeah.
Yeah. Okay, so we're not going to have you hit your bets. Somebody want to confirm or deny? Are you going to put a decimal there?
No.
No. Why?
He only wants 2 sig figs.
Because we only want 2 sig figs. And we know that this number here has a lot of uncertainty in it. And so we want to make sure that we account for that uncertainty. Okay? Questions? Okay, so what about multiplication and division? Let's see. Okay, so we have 234,000 point times 0.001 divided by 100. Okay.
What the heck?
Actually, let's do this. Okay, so how many sig figs do I have for that first number?
Six.
6.
Okay. And the second number?
Two.
And the last number?
3.
5.
5.
So is it 5 or 3?
5.
It's 5. Okay. So when I multiply it, what is my answer? And how many sig figs should I have? So let's just go with the answer first. What is going to be the answer?
$2.34.
You got 2.34? Okay. So then my final answer should be
2.3. 0. No, just 2.3.
2.3. That is correct. Okay, so again, we should end up with only 2 sig figs, right? Because the smallest number of sig figs is 2. Piece of cake, you guys remember all of that, right?
I wrote it down.
Okay, good. So the homework should be a piece of cake for chapter 3, right?
Better than that first quiz I did.
Yes.
Okay, are you guys ready for the next part? Ready to move on?
Yeah.
I think we are.
Okay, so last we left off, we were just getting ready to start about the metric system versus the United States customary system, which is the empirical system. So these are some of the conversions that you should remember and not memorize, but remember. You have your conversion sheet and you have a lot of the conversions on your conversion sheet. You guys know that those are under modules, right? At the very bottom under resources. I have one more to add, and I keep saying I'm going to do that. So I have to remind myself. It may even already be up there, and I haven't realized it, but I have to check to be sure. So your conversion sheets you can use on the exam. So I would print it out and make sure I have that copy. Okay, but you should be getting used to it because you're going to be using these numbers pretty consistent. Okay.
Can we
Because
highlight on
Yes.
the paper and still use it on the test?
Yes, you can.
Okay.
Okay, so like 1 inch, is 2.54 centimeters. 1 pound is equal to 453.59237 grams. Or we also know that it's equal to 2.2 kilograms. Or I should say 2.2 pounds equals 1 kilogram. 1 gallon is equal to 3.785411784 liters. So in length, so 1 foot is equal to 12 inches. 1 yard is equal to 3 feet. 1 mile is equal to 528 feet. 1 pound is equal to 16 ounces. 1 quart is equal to 32 fluid ounces. And 1 gallon is equal to 4 quarts. So
Can
if
you
I
go
have a
back to
size,
the miles again? 58 what? 5860?
1 mile,
58. Oh, yeah.
5,000,
5280.
yes,
All right.
5,280 feet.
Are your notes up? Like, are you able to post these now?
Yes, they've been up since the very beginning. So if you go under modules, they should be available for downloading.
Okay.
Okay. It will say PowerPoint. It'll say PPT at the end. It's a PowerPoint presentation. Okay, so a soft drink manufacturer is converting from USCS units to metric units. If the quart bottle initially is to remain at the same volume, what number of milliliters should be printed on the label? So where am I going to start at?
The
What's my
gallon.
given? What was that?
Break the gallon down into a quart. So make that divide 3.785411784 by 4.
So you're saying, let's take it step by step, okay? So you're saying 1 gallon equals how many quarts?
4.
And we also know that 1 gallon equals what?
3.785411784 exactly.
And what were the units for that?
That's 784, not 487.
7. And what were the units?
That's liters.
Okay. Okay, so what is another conversion that we're going to need? Because we're looking to get a number of milliliters.
Mental analysis is going to be the
We would just need to know how many milliliters there's in a liter.
Okay, so how many in 1 liter, how many milliliters are there?
1,000.
Okay. So what are we starting off with? What's our given?
1 quart.
Okay, so I have 1 quart. Okay, so then for my first conversion, what am I going to use? What's going to be on top and what's going to be on bottom?
3.7 blah 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 liters is going to be on top and 4 quarts on the bottom.
and 4 quarts. Okay, so then quarts cancel. That gives me liters. So what's next?
$1,000 milliliters at the top and 1 liter at the bottom.
Okay, and that should give me my milliliters that I want. So what do you guys get?
Three 3.8 liters.
Are you sure?
Probably.
So if I have 3.785 times
Times.
1,000 divided
It's
by
actually
4.
It's actually 3.7851.
Okay, so if I have 3.7851 times 1,000 divided by 4, is that going to equal?
Oh, divided by 4.
It's 946 milliliters.
Okay, so if I was asking you for significant figures, what would you give me?
How many significant figures?
Let's say this was given to us as just one period. So how many sig figs would you give me?
1.
So what would be your answer?
900 milliliters.
Okay. Okay, piece of cake. Yes, no, maybe?
Okay, I'll buy it.
You'll buy that it's a piece of cake?
Yes.
Okay, good. Okay, ready to move on?
So my answer is 946 or 900.
Your answer would be 946, but if I was asking you for sig figs, and let's assume that it said 1 quart bottle,
It'll be 9.
it would be not 9,
0.9.
it won't be 0.9 either,
Oh, wait, 900.
it will be 900. Don't forget your placeholders. Okay, so temperature. So I don't remember if did we talk about temperature? Probably not. So there are 3 scales that we're going to be working with. We have the Fahrenheit, we have the Celsius, and we have the Kelvin. What was that, Cole?
I didn't say anything.
Oh.
I mean, I can talk if you want.
Maybe later. Okay, so if we have those 3 different scales, we need to be able to use all 3 different scales. So this scale here, this changes Fahrenheit into Celsius. So we can rearrange this equation. So that we can rearrange this equation algebraically so that we can convert Celsius to Fahrenheit, or we can go from Fahrenheit to Celsius. Okay, so the other equation is based upon Kelvin. Kelvin is a form of temperature you guys are probably not familiar with because it's primarily used by chemists. And so a Kelvin, 0 degrees Kelvin.
That's absolute
So
zero.
is absolute zero. That's correct. And so at absolute zero, all, well, we did talk about this. All elements or all molecules stop moving, right? So remember when we talked about, molecules or elements or compounds, they basically move, they vibrate a little bit, right? So even when they're solids, they're moving, but it's very little. But at absolute zero, everything stops moving, okay? And so that's going to be equal to negative 273.15 degrees Celsius. Okay. So we can say T Kelvin, temperature in Kelvin, is going to be equal to temperatures in Celsius plus 273.15. Okay. So these are your three equations to convert temperatures. Okay, so let's kind of test this out. So if water freezes at 32 degrees Fahrenheit, so what is the temperature in Celsius? Which equation am I going to use?
Negative 32?
Not negative 32, at 32 degrees.
Okay.
Which equation am I going to use to change from Fahrenheit, 32 degrees Fahrenheit, to Celsius?
A.
Okay, so I'm going to use A, right? So I put in 32 degrees. So what is 32 minus 32?
0.
And divide that by 1.8. So 0 divided by 1.8
0.
should be 0, right? Okay, so we know that it's 0 degrees Celsius. Okay, so if I have 0 degrees Celsius, how much is that in Kelvin? Which equation am I going to use? A, B, or C?
C?
Okay, so 0 plus 273.15. That's going to equal, is that correct? 0 plus a number, isn't it always going to equal that number?
Yes.
Piece of cake?
Yes.
The units would be Kelvin. Okay, any questions?
So you're not spelling Kelvin out, you just put in a K, right?
Yes, so we abbreviate it as just K, yes. And then as we would do for our degrees Celsius, it should be 0 degrees Celsius. And so we use the degree sign for Celsius and just K. There's not a degree for Kelvin.
Okay.
Okay. Questions? Okay, so let's say water boils at 100 degrees Celsius. How much is that in Fahrenheit? And how would I calculate that? Which equation would I use?
B?
B, okay. So 1.8 times 100 is what?
.5985.
1.8 times 100.
Oh, wait, never mind.
180.
180. 180 plus 32?
Oh,
212.
Okay. So if we pay attention to the water on our stove, water will start boiling at 212 degrees Fahrenheit. So if I wanted to calculate Kelvin, and again, we're starting out with 100 degrees Celsius, what would I do? Which equation would I use?
Add the 273.15
To what?
to the 100.
Okay. Piece of cake?
That's what I got.
Yeah.
Okay, good. So let's see how well you guys got this down.
Oh, Lord.
Okay. So this basically is just showing us how they equate to each other, right? Okay, convert 288 Kelvin to Fahrenheit. So how would I go about doing this?
So isn't Kelvin to Fahrenheit just subtracting 459.97?
So where did you get the 459.97?
I don't know. I think I made it up. Or 273.15.
Would that give me Fahrenheit or would that give me Celsius?
It'll give you Celsius, but then you'll have to convert Celsius to Fahrenheit, right?
That's correct.
Is it 58.3 Fahrenheit?
What was that?
58.73.
58.73. Yeah, that would be the correct answer, yes. So the way that we could do it is we'd go 288 Kelvin minus 273.15, and that's going to give me my degrees in Celsius.
You're not done with class, dude.
That's 15.15 Celsius.
15.15, are you sure? I got
Well, if you're
14.85.
I'm subtracting 273.15 from 288, right? Oh, wait.
288 minus,
No. I messed up. Simple.
And we know that TF is going to be equal to 1.8 times 14.85 plus 32
Is 58.73.
So if we did 2 sig figs, our answer is going to be
59.
Yep.
piece of cake.
Give grandma a kiss. Bye-bye.
I love you.
You're a good boy. You be good
Okay.
for mommy.
Questions?
Mm.
Concerns? Cash?
No.
No? Good. Okay,
Can you do another problem?
maybe.
Holy Toledo.
Okay, so what I want you guys to do now is I'm gonna put you guys in groups, gonna give you about 8 minutes to work. And then I want you guys to come back and fill in this table. Okay, so take a picture of the table. You can use that save button and annotate. Gonna throw you in rooms. Are you guys ready?
Sure.
Got it.
Yep.
Ready.
Okay, rooms are open.
Like
to-
right on
oh, like write it in. Yeah, no. I'm not sure how to. Oh, annotate. Okay.
Yeah. If not, I could do it for you, but
How do I make it bigger? Mix. Is that good enough? It's also blue.
um,
Hmm. Oh, lordy. Is that good?
yes, that is perfect.
Okay.
Okay. Does everybody agree with her?
Yep.
Yep.
Yep. Okay. Now let's do breakout room 2. Giselle, can you fill in the last Fahrenheit rectangle?
Yeah. Oh, there.
Does everyone agree with her?
Yes.
Okay.
Oh wait, I think
Or
it's
wait, I
supposed
have
to be
195.
5. Yeah, 195. That's what I meant to put.
Okay.
Oh yeah, I have 1.195.53.
Yeah,
Okay.
that's what I meant.
Okay. Then if I asked you to round it to 3 sig figs, because that's what our Kelvin number is, what would that round to?
195 or yeah, 195. No, sorry, 196 because it has something afterwards.
There we go. 196. So, yep, depending on how specific we want to be with sig figs, 195.53 or 196. So, oh, cross that out. So, just 196. Good enough. Okay. Let's do Aubrey. Can you fill in the first Kelvin rectangle? Aubrey?
Yeah.
Can you fill in this Kelvin rectangle?
The top one?
Yeah, the top one.
Okay.
Yep. Everybody agrees?
Yes. But
Cool.
with Kelvin, it's 3 sig figs, so 248.
Okay. Yep. 248 works. 248.15. Temperature is weird for sig figs because we have this 273.15 calculation that we use. Sometimes we use the whole thing. Sometimes we just use 273. Just depends on how we're feeling that day. But anyways, let's do Mandy. Can you fill in this Kelvin Celsius rectangle underneath the -25?
Yep. Mm. 41, I think.
Yep, 41 looks great. Okay, Davina, can you fill in this Kelvin rectangle right here, the last one?
Yes.
Okay, everybody agrees with her?
Yeah.
Okay, then finally, Erica, can you fill in the last rectangle for us? Okay, does everyone agree with her?
Yes.
90.8, 91 if we wanted to round. Yep, that looks good. And okay, that is it. Good job. Be comfortable with this. This will be on your exam from past experience with Dr. Henry. This pretty much a table like this will probably be on it. So be comfortable with converting from Fahrenheit, Celsius to Kelvin, back and forth. Other than that, you are free to go.